Welcome back. All right, it's a new week, and it's still No Shave November. All right, well, anyways, so last week we did this assignment right here, 11-8. So make sure you get that turned in. Today we're doing the backwards of this. So this was given equations, graph a system. Today, given a system graph, write the equation. Make sure you don't have headphones in, that you're hearing what I'm saying. Please. All right, so we do have a quiz Wednesday, a couple days, 2 days from today, so make sure you're doing your work. That'll prepare you. Now, this warm-up, we've done this before, right? Solve for y. Like we've done it, I don't want to say every week, but very often we've done this. Here's why. On the EOC, you're going to have to like graph some of these, and you cannot graph this in Desmos. Everybody, this, the way it is, will not graph in Desmos, ever. So you got to be able to get it into y equals. You might keep seeing these on tests and assignments, like today's assignment, where you have stuff like this that you need to graph. So again, on our warm-up, I'm showing you over and over and over until we for sure have it in our brains. You got to be able to solve for y. Here's how you do it. Here's a reminder. If I'm solving for y, first I have to move the x, right? Now this x is positive 3x, so what's the opposite? Minus 3x, yes. Do y'all remember me saying minus 3x? The mx goes in front of the b, okay? So that minus 3x is going to go first, and then the minus 10 will go second. So when I bring this down, okay, it's not just 5y. There's a minus in front of it, right? So that's like a negative 5y equals the mx, the negative 3x, is going to go in front of the b, minus 10. Please notice, they're not like terms because they don't both have an x, or they're not both just a constant number. That's why we don't just add them together. Now, last step. To get rid of anything in front of y, we have to divide. Okay, so to get rid of that negative 5, we divide by the exact same number, negative 5. Divide by negative 5. Divide by negative 5. And just a reminder, when you have these fractions, like negative 3 over negative 5, you can just type it into Desmos, negative 3 over negative 5, and then press the fraction button. So it didn't reduce, but the negatives canceled out. So it's just 3 over 5x, and then negative 10 over negative 5, well, gives me 2. So it's positive, so plus 2. Okay? You're going to keep seeing this because you've got to be able to take that standard form and get it into slope-intercept form. You have to be able to move the x, divide, make sure it's in the right order, and then reduce any fractions. You must be able to do that. Now, here's the notes for today. Like I said, today's backwards of the last 2 days. We're taking a graph of systems and working backwards to get the equation. Oh. Now, is the test on? All right. Do that first, please. Here we go. All right, writing systems of equations from graphs. All right, everyone's with me? This shouldn't be too long. This is kind of stuff we've already done. We've already gotten an equation from a line. Now we're just doing it twice, pretty much. So to write the system of equations, we need to write the equation of each line. That's it. Okay. So here's a reminder on how to do this. So find the equation of line K. So does everyone see K is right here? I'm going to outline it. It's this line right here. Now, we need to find the slope and the y-intercept. Do y'all remember in the equation y equals mx plus b? M is the slope, b is the y-intercept, m is like the mountain slope, rise over run, and b is the beginning, where you begin to graph. Okay. How do I find the slope from a graph? Well, do you see that there's 2 points? Go ahead and make these nice and bold. We got these 2 points on the line K, right? And to find slope, we're going to count the rise over run. Okay, so when we count rise over run, do I start on the left or the right? Like I'm reading, I do start on the left. Okay, so which point is further to the left? Negative 4, 4. So you must rise before you run. I see people running before they rise. That's not how it works, right? If I'm on the floor, I gotta stand up before I run, right? So the weird thing about this is that which way does this rise? Well, it doesn't go up, it goes down. 1, 2, 3, 4, 5, 6. Does everyone see that starting on the left, it has to go down when I quote unquote rise. So it's weird to say rise down, but it's possible. Just remember, down is negative. It's not just 6, negative 6. And then we always run to the right, like an old Mario game. 1, 2, 3. Down 6, right 3. My slope is negative 6 over 3. Now, your Desmos can help you figure that out. Okay, or mental math, but negative 6 over 3 is negative 2. That's my slope. Cool. Now, the y-intercept. Where does it cross the y-axis? Okay. So I'm looking, where does the line touch the y-axis? Scratch paper. Oh, it's actually on there somewhere. On the chart. Okay. But don't. Okie dokie. Now, the y-intercept. Where does this line cross the y-axis? So here's y. It touches right here. What number is this? Negative 4. So does everyone see? We counted rise over run for my slope. And then I see this line touches right here at negative 4 on the y-axis. So now that I have m and b, I'm going to write y equals m x plus b. Since it's negative, it's minus 4. That's it. We're just writing an equation from a graph, finding rise over run slope, finding the y-intercept. Now, let's do it again, but this time for line L. Okay, so I'm going to use a different color. Cool. And let's find the slope. Now, the 2 points are here and here, right? So I start on the left, which is right here. You write this down. You don't need to be on the Chromeboard, please. Okay, so you're gonna rise on the left, 1, 2. You're gonna run, 1, 2. Okay. Cool. So the slope is 2 over 2. Hopefully you know that 2 divided by 2, or any number divided by itself, is 1. So basically it goes up 1 over 1, up 1 over 1, which is true. Okay, what's the y-intercept? Where does it touch the y-axis? So again, here's y. It touches right here at 4. So my equation is y equals mx plus b. So y equals m, which is 1, x plus b. Now usually you don't see the 1, right? It's just x plus b, so plus 4. If you write 1x plus 4, it's okay, but this is how you're going to normally see it. Just x plus 4. Cool. So down here, you're just going to rewrite these formulas. Equation 2 was y equals x plus 4. The first one was y equals negative 2x minus 4. That's it. And that's what you're going to be doing on the assignment today. So let's try another one, but I want to make sure everyone's got this down first. So 1 second. Make sure you finish this, and we're going to do the next one in just a second. All right, next one. A little bit faster here, same idea. Line M. Here we go. Line M. I'm going to draw over it. Now, notice, does everyone see there's not points? Like, there's not selected points on this line? You will need to select the points. Just remember, they need to be off the grid. All right, so let's pick 2 points on the grid. Right here and right here. If you pick other points, it's okay. It should give you the same slope, no matter what, okay? But if you pick 2 points like this, to find the slope, we're going to rise over run, starting on the left, right? The left. So here's my left point. It rises 2, and it runs 1. 2 over 1 is 2. Don't forget this invisible math. If it's over 1, it's just whole number. Cool? Now, what's the y-intercept? Where does it touch the y-axis? Right here at 4. So I got a slope of 2, a y-intercept of 4, so y equals 2x plus 4. And you can write it down here already. That's your first equation. Slope on line N. So for this line, I'm going to make it red. The slope, I got to pick 2 points. So this is on the grid, and this is on the grid. It's got to be exactly on the grid. Not above, not below, not slightly almost there. So if I start on the left, this one rises not up, but down 2. That makes it negative 2. And then it runs 1, 2, 3. I get negative 2 over 3. It doesn't reduce, but you can always try and Desmos. You always want to. And then where does it touch the y-axis? Boom. At negative 4. So if I have my slope and my y-intercept, I can rewrite it as y equals mx plus b. Y equals negative 2 over 3x minus 4. And you can write it in the second equation down here. Okay. one little extra thing that we talked about on the last assignment, once y'all finish writing, do y'all remember finding the solution of a system? Like, where's the solution to this system? Like, in general, you got two lines, where do you find the solution? When these two lines touch, I know y'all are shy today. When these two lines touch, that's the solution, right? Y'all see it on there, like where they go, where they cross? Okay, it's like two cars. Bam! Solution, okay? So you should be able to write that point. So everyone can see it on this second example, right? Now go back up, or look back up on your page. Do you see that this solution is like not on the grid? Like, you could probably give me like some like estimation, like roundabout. It's kind of like maybe negative 2.5-ish, kind of 1.5-ish. It's not exact. So here's the deal. If you don't see an exact grid answer on a graph, how could you get the exact answer using Desmos? What could I do with these two lines that I just got down here? Couldn't you graph them in Desmos and see where they cross? When you click that intersection point on Desmos, it will tell you the exact solution, fraction, decimal, however you want to write it, okay? So again, we're doing this for a reason. If you don't have an exact grid answer, use the y equals equations in Desmos, click the intersection, that's your solution. All right, so I'm going to leave it right here, and I'm going to pass out your assignment. This is a one-day thing, so you want to knock it out today. The back of it is, the back of it does have some standard form graphing questions. Think of our warm-up. You got to solve for y before you can graph it or compare it to a graph. Okay? So, no problem. Let's get going on this.